So here's some help with Unit 3, Section 1. And there are two major concepts that are involved in Unit 2 section, or Unit 3, Section 1. Percent purity is the first, and that's what we're going to talk about. So the idea behind this, I think, can be kind of complicated or at least hard to understand. So far when we've done any sort of calculation with percent concentrations and things like that, we've assumed that the reagent that we're working with was 100% pure and didn't have anything else added. So in that situation, we would say, hey, 5 grams of glucose is, if we were to weigh that out, a perfect 5 grams. And life is great and happy and wonderful. Problem is, so often when we go to our shelf, and assume this is something we would see glucose in, we look at this guy and it says glucose 98% pure. And we say, oh crap. Because 5 grams of this stuff, if we were to look at it, is not 5 perfect grams of glucose. What we've got is mostly glucose, but we've got this extra amount of stuff in there. That is that other 2% impurities. So it's these impurities that are going to throw our calculations off if we don't correct for them. Because if I have a problem that asks for 5 grams of glucose, that's what we need is 5 grams of glucose, not 4.9 grams of glucose and another 0.1 grams of other stuff. I need those 5% or those 5 grams. So what we do in the lab is we take this idea of going from a pure amount needed to how much of that impure stuff that I have on my shelf am I going to need. So let's take a quick look at this. And interestingly enough, it fits right on with what we are doing here. So I'm looking at the homework for Unit 3, Section 1, which is Gary's self-exam progress, self-evaluation progress exam number 2. It's kind of the way Gary words it, and it's in his clinical chemistry packet. If you don't have clinical chemistry yet, you should be able to find this just online. So, this first question asks, you need to make 100 milliliters. Let me make sure you guys can see this, what I'm looking at. So, problem, and I know it's tiny, you probably can't read it here, but I'll write big. So it says, you need to prepare 100 milliliters of a 5% weight volume glucose solution using anhydrous glucose, and we'll talk about the anhydrous thing, which has an assay value of 97.6. So 97.6 tells me that's how pure it is. So how many grams of that glucose are we going to need? So I know that a 5% solution tells me that I would have 5 grams of that glucose in every 100 milliliters. Now that's all well and good if the glucose that I was dealing with was perfectly pure. The problem is we've been told it's not. So I need to go from 5 grams of pure glucose to how many grams of the impure stuff I would need. Now I think it's important to always stop and think, okay, if 5 grams is talking perfectly pure, and now I've got something on my shelf that has other stuff in it, then it would make sense that I'm going to need more than just those 5 grams. So, and I kind of like to draw it and picture it. So if this is 5 grams of perfect stuff, then add some impurities there, and I'm going to need a little bit more than just those 5 grams. So the way we do this is to go from an amount of pure to an amount of impure that we need. You do however much you have of pure stuff times 100 over my percent purity. In this case, it's 97.6. So, when I do this in my calculator, 5 times, and I like to keep it in parentheses, although it doesn't usually make a difference here, because we don't have multiple sets of numbers or functions. But I crunch it out like that, I get an answer of 512, or 5.1229. Or in other words, 5.12 grams. And that makes sense because it was pretty close to being 100% pure, but we were maybe just a little bit off here. So instead of needing that perfect 5 grams, I've got to account for this other stuff that may be in there. So out of my 5.12 grams, I know that the 5 grams of glucose are accounted for, and then I'm taking into account another 0.12 grams of that other stuff that isn't going to contribute to the 5% solution that I'm trying to make. So that's going from a pure amount to an impure amount, and we just do that by multiplying the pure quantity times 100 over my percent assay or percent purity.